Hello, my name is Mr. McNeil, and this is Vocabulary Breakdown Kinematics, Part 4. So in this vocabulary breakdown, we are still continuing to talk about motion and kinematics, which is the study of motion. In this section, we'll be talking more specifically about motion and the relationship to our previous vocabulary words. With that, let's start with motion itself. So when we talk about motion, we talk about two ideas. We talk about velocity and we talk about speed. Both of those are a way of describing motion. Now, if you remember, velocity is what's known as a vector, which means it has direction. So velocity tells me about where and how fast an object is moving. So is it moving to this would be the northeast. It's moving to the northeast at 50 miles per hour, where speed simply tells us how fast it's going. Okay, but they are when we talk about motion, those are the two concepts that come up. Those are literally motion. Everything else we're talking about in those vocabulary sections from 1 to 3 are all talking about how it relates to velocity. Now let's move on to the next one. So this is displacement and distance, and they're both results of motion. So starting with the top one, displacement is the result of velocity. So if an object is moving, then we can expect with time that it'll experience a displacement. So if an object is moving at 30 meters per second and it's doing it to the northeast, I can predict how much displacement that object would have in 5 seconds, 20 seconds, 100 seconds. But that prediction, that displacement, is the result of that velocity. And the same can be said about distance. Distance is not talking about velocity. Instead, it's talking about our other type of motion, speed. So remember that distance is just a number. It's how far I've traveled. It's the number of steps I've taken. It's not referencing anything other than that path. So just like speed is not telling me what direction I'm going, distance is just telling me how far I've gone. But both of them are a result of motion. The next section is changes. So this one's a difficult one to kind of put our head around. Acceleration has been used inappropriately, unscientifically, I should say, not inappropriately, in our civilization since the dawn of whatever. But acceleration specifically is talking about changes in motion, and specifically the change in my velocity. Now, when we talk about changes in motion and we're talking about our speed, we often use the word acceleration to talk about an increase in speed. And we use the word braking to talk about a decrease in speed. The problem comes when you're trying to take that idea of acceleration from speed and apply it to velocity. Because velocity is simply a change. Acceleration is simply a change in velocity. So in the case of speed, I might have an acceleration at 2 meters per second, which means that the car is going faster. I might have a braking of 2 meters per second, which means that the car is going slower. But when I'm talking about acceleration and velocity, that 2 meters per second could actually be braking or going faster or even changing direction. So it has to be understood that when we use the word acceleration, we are not using acceleration as it applies to speed. And acceleration could, in fact, be braking. It could be, in fact, speeding up, going faster, I should say. Or it could even be turning. So be very careful when you're dealing with acceleration. It's the thing that you really have to think about for a second as you're evaluating these problems. And when we're dealing with equations, we'll talk more about how acceleration and velocity are related and how can I tell if it's going faster or slower. The next section here is talking about different types of motion, and that is average, instantaneous, and relative. So average velocity, most of us are familiar with the concept of an average, and all we're talking about is over a length of time, what is the average velocity? So if my car went here, or I started from this point and ended up at this point up here, I could calculate the average velocity if I knew the amount of time it took for me to travel that distance. To travel that displacement. This displacement divided by the time it took would give me my average velocity. But imagine instead that the car or object, we'll call it a car, actually took this path to get to that same point. It took the same amount of time. It got to the same point, so its displacement is identical. The average velocity for this would be represented here. But instead, if I looked at the instantaneous velocity, I have to look exactly at that point I'm referencing and determine how fast that car is going and in what direction. Okay, so average velocity is referring to the total displacement divided by the total time. The instantaneous velocity is referring to the velocity at a given moment. Cool? The last concept is relative velocity. Now, relative velocity is kind of interesting. The idea of relative motion is us. If you're sitting in a chair right now and you're listening to this video, more than likely you are believing that you're not in motion. Or if you have it on your phone and you're walking down the hallways and you're believing that you're traveling at maybe 1 or 2 meters per second. Relative velocity just simply states that number, whether it's 0 or whether that's 1 or whether that's 200 or whether that's 10 million, is a result of a different reference. I believe that I am traveling at 0 meters per second because everything around me, the things that I'm referencing, are also not moving to my point of view. So that means that I am referencing myself, making it relative to everything to make myself believe that I'm traveling at 0 meters per second. The truth is that it's not the case, because the Earth is spinning, our solar system is spinning, our galaxy is spinning, so there's all of this additional motion that's going on. But because I am referencing myself, because I'm looking at my environment and I'm picking up something in my environment to say that isn't moving, and because I am not moving with respect to that object, I am also not. And you can make the same statement when you're walking down the hallway with your phone. So I'm watching this video and I'm on my phone and I'm walking down the hallway and I'm going at about 2 meters per second. I believe I'm going at 2 meters per second because I know the lockers in my hallway or the tiles on the floor or the lights overhead. I believe that those are motionless. They're not moving. And I am relating myself to that object. I'm using that light or that locker as my reference. And I am moving away from those objects at about 2 meters per second. So I believe that I'm traveling at 2 meters per second because I'm referencing that light. Now, I could, in fact, go walking down that hallway with my phone and I'm just walking along and I'm watching the lockers and I'm looking at the lights and I'm looking at the tiles. I could literally say, I'm traveling at 0 meters per second. And those lockers are moving at 2 meters per second away from me. And it's fine. That's actually acceptable. That's a real answer. Okay? That's actually acceptable. There's cases that we would rather talk about the lockers in motion. Relative velocity is a really interesting concept, and we'll deal with it a lot more in electricity and magnetism. There's a problem that comes with that. Cool. Another really interesting thing about relative motion is change in relative motion, acceleration. if you have a change in relative motion, you have an acceleration. If you have a change in motion, you have an acceleration. And if I'm going at 2 meters down the hallway and I turn and I stop, my relative motion is at 2 meters per second. Or if I believe that the lockers are moving down that hallway and they come to a stop because I stopped, I get the exact same acceleration. Acceleration never changes its reference. If it's 2 meters per second, it's 2 meters per second. It's interesting. I often tell people that if you can feel it, then it's not relative. Acceleration, there is no relative acceleration in this class. Okay, cool. All right. We will continue on with the series of vocabulary breakdown, and then we'll be moving on to some other things. So if you have any questions, please ask, and I'm more than happy to answer.